Good afternoon. It's great to be here, and like previous speakers, I'm delighted to be here and speaking on behalf of the consortium. But I suppose what I really would like to say from the off is that we take for granted sometimes that we have these types of events, and I'd just like to thank Alan and Sita and Suzanne for hosting events like this on our doorstep, and I think that's really important. My name is Mark Costello, and I'm here today with my colleagues Elena Bea from Ferrovial and Alistair from AMI. And we hope to take you through what is our journey on the M8, M73, M74 project. We've titled I noticed this morning one of the headlines on the paper was the American Revolution. We've called this our revolution on the M8. So have we achieved everything we set out to do? Well, we've achieved a lot, but like Anne Kemp talked about this morning, I'd like to give an honest account of ourselves over the last 2.5 years. Our project team is multidisciplinary, diverse. I'm a South West Common man living in Galway. Elena is from Alicante, Alistair from Belfast. And our project is multidisciplinary too. The design is being carried out across a number of offices, Cork, Dublin, Galway, Belfast, with the design team or with the construction team primarily located in Motherwell in Scotland. Who are the project team? Ferrovial, Lagan, AMI, RPS. Well, we had a mutual objective to develop BIM in the infrastructure sector, and I suppose we've heard a lot of good presentations here this morning about BIM for buildings and BIM in that area. And a lot of what I do in my background is roads, transportation, rail, and this was an opportunity for us to see could we get into BIM in the infrastructure sector. Also, like the last speaker, I suppose the recession, one of the good things to come out of the recession was to take us all out of our comfort zone and to deal with the issues of working in a collaborative level 2 BIM environment. The M8 project, a little bit about it. It's a large project. It's an improvements project which completes the central Scottish Motorway network. It's designed to improve safety, reliability between Glasgow and Edinburgh, and it will improve journey time improvements. There will be journey time improvements of up to 20 minutes along various aspects or areas of the scheme. It's a DBFO type contract, and it's a significant investment of over 600 million in Scotland's vital trunk roads. 350 million euro in terms of construction cost, and it's a 30-year O&M term. The contract was awarded back in February 2014 and is due for completion, all going well, in 2017. The graphic on the right just gives you some idea of the people involved and the type of contract that it is. It's one of the busiest junctions in Scotland. It's over 100,000 vehicles passing through it on a daily basis. All the traffic currently of the two corridors has to pass through and negotiate the existing at-grade rate junction. The construction of the new underpass would provide a free-flow junction to some significant traffic delays that are occurring there at the moment. In terms of innovative use of BIM, and what does that mean? Well, I suppose you take a complex junction on a very large project like this, and you find out very quickly that you need to be innovative and you need to learn on the project. Raith Junction is very complex. It's a 3-level interchange. It's located in a floodplain, which would really, I suppose, have determine or would require a particular approach in terms of our design. It's also in an area of extreme environmental sensitivity. The high water table level and the existing traffic flows would need to be maintained at all times, as would the existing drainage need to be maintained at all levels during the construction process. It's sharing a footprint with the existing roads in many areas, but at significantly different levels, and that again would provide some problems for us in terms of the traffic management and our approach to that. But again, using our BIM model and the types of processes that we would put in place, we would work through those. We would also need to provide safe pedestrian access for the duration of the project. Some stats just on the junction itself. It's 560 metres in length, 12 metres deep, 35 metres U-section with 3 new bridges, two pedestrian footbridges and 5 existing signalised junctions. We talked earlier, Thomas talked earlier about quantities and scale. There was 1,500 secant piles used in the construction at rates, 300 anchors and more than 20,000 cubic metres of concrete used in the construction at rate. It's easy to forget that back in 2014 we didn't yet have a mandate and there was no EIR required at the time. So if we wanted to use this project or we wanted to avail of the opportunity here, how could we overcome this? So the parties came together and we put together what we call a joint BIM proposal, effectively to replace the EIR. Remembering again that it was 2 years ahead of the mandate. We would document and control, document and deliver our approach through a BEP, which we would in place in response to this, and we would do it in accordance with the standards that we have become familiar with. We would also take into account, as best we could, the soft landing's objectives of aligning the interest of those that would design and construct the project with those who would eventually use and have to manage it. One of the key areas for us was education and training. And again, coming out of the recession, working from Ireland and having to work on these types of projects in the UK, we looked around at the time and we just didn't see the type of solutions that we needed to work on these types of projects. We needed people trained at all levels across our organisations and from graduate to right through to management. And we needed to decide what type of particular training they would need. We looked at the development of some new courses with different academic institutions, and to give credit, GMIT came up trumps here, and together we developed a new higher diploma in engineering in BIM, and we're working through that, and we will continue to do that with them. We also needed a roadmap and certification. Lots of tenders starting to ask for BIM, even in advance of the mandate. And happy to say that we achieved certification at the end of 2015, working with the BRE. I suppose the main part to put up there, the sign, is just to show, this was, how we were working through what were our objectives, our joint BIM proposal, through our execution plan. We had a kick-off meeting between all the different parties. On the bottom left there, you'll see we had weekly meetings in various locations across our offices here and in Scotland. And as we went through the project, we documented our lessons learned, warts and all, and that was something that was quite challenging, but maybe refreshing now that we look back on it. Again, in terms of interoperability, we chose to use the infrastructure design suite at the time. Civil 3D in terms of alignment, structure, utilities, drainage, those types of things. Revit and Tekla for the culverts and structures. And we federated these models through Navis. And again, the design team and construction team working together, and loads of arguments and all sorts of things in terms of, had we clashes and whose fault is this and all of that type of thing. But Elena now will hopefully take you through our transition from the design into the construction, and I'll quickly finish up with some lessons learned.
Thank you, Mark. So as you well mentioned earlier on, this is a design and build project. So the construction started about 2.5 years ago, and it's still ongoing. And it's very obvious that the design outputs are really important for us. The way our engineers would traditionally work is they extract all the required information from shells or 2D drawings. The communication we have with the designer is normally via conference calls or sketches that we would send by email. And in terms of the setting out, once again, our surveyors are having to extract all the information directly from the drawings and the shells. So the very first benefit that we obtain by using the BIM technology is that we're able to extract all that information directly from the model. Let's imagine that next week we have to install a new run of drainage. We obviously have to order the materials in advance, so we need to know how many linear meters of pipes we're going to install, what's the diameter, what levels are we going to be working, do we need trench support or not. By clicking on the pipe itself in the model, all these details are provided just within seconds. Once we get the design, first thing that we do is we check it to ensure that there are no site constraints that might require a change in the design. When that has been the case, we have been modeled ourselves what we would need on site to happen. We would have sent that back for validation to the designers. And obviously, this has been a very efficient way of communicating. It's very hard to try to explain sometimes on the phone to a designer that is based somewhere else with a different accent also, that you need to raise several areas of the alignment in a certain way to make it work on site. So once you know what you're building, we need to start thinking about how we're going to do it. The software in this case has allowed us to move from a traditional way of doing things with 2D drawings and schedules into a virtual animation in 3D of how the interchange is taking shape. But obviously not everything comes easy. This is a very powerful tool to ensure that we do not have any clashes during the construction stage. But it also takes time to create these sort of 4D animations. Sometimes, depending on the software that you use, you even have to go back to the original model and do some changes in the way of breaking up different elements so you can select different areas of the alignment. And also, if we can imagine the type of scale of projects that we've got, this is very different from a building. There's one of the dimensions very predominant over the other two. So if you can imagine how a 4D sequence of the whole M8 with the 20 kilometers would look like, you're struggling to really see what's happening everywhere. So you need to start focusing on the areas that are really of importance to you. The setting out process has also been improved. We're now able to obtain all the coordinates, all the levels directly from the model by clicking on every element. So we're really being more reliable. We're cutting down the mistakes by avoiding intermediate steps. And what happens at the end of every month? We all have to be paid. And so our engineers are having to remeasure all the cubic meters of concrete poured during the month, all the tons of steel installed. And it's a task that is very time consuming, it's very tedious and mechanical. And the model can really do it for you in no time. And what's even better is that if there's any change in the design during the construction process, all these quantities, all these spreadsheets are automatically updated. And that helps us a lot in keeping the budget under control. So one of the biggest problems that we've had during the construction is the lack of room on site. So one of the main structures in the interchange had to be built into halves. This is to allow 4 lanes of traffic to be maintained all the way throughout the construction process. And we've had to work out a lot of cross-sections like the one we've got in the image here. Somebody that has done this before will know that this takes time. You're basically checking different drawings in order to produce the elements that you want to show in the cross-section. It's very easy to make mistakes in levels or dimensions or to forget different elements. So when you are able to do these cross-sections with the model, again, it saves a lot of time. And you do not forget items like existing utilities or existing drawing or existing drainage, excuse me. This is just a couple of images from the site of this particular bridge being built with the traffic right next to it. One of the biggest challenges in this project, as Mark was mentioning earlier on, has been the traffic management. In order to create, well, I have to say first, really to put you into context that the interchange is overcapacity at this stage, but we still have to be able to build all the new works without causing much disruption. So it's very important for us, and we've had to design different temporary alignments in order to divert the traffic to create enough room for us to build the works. But the problem is that before we can run the traffic onto these new temporary alignments or we can close any lane on the road, we have to get the agreement from a series of consultees, such as local authorities, councils, Transport Scotland, Police Scotland, different road maintainers. And sometimes they're not very familiar or they're struggling to understand how the traffic is going to flow by looking only at a PDF drawing like the one we've got at the top. So we've been able to produce these drawings directly from the model. It's helped them a lot in a way of imagining how the traffic is going to flow. Is it going to be safe? Is there going to be enough room? It's really been very effective in that way. The power of the image again, when you're trying to explain a local resident what you're building in front of their houses, if you use an image like the one on the left-hand side with the alignment or the new alignment shown in red, they're really going to struggle to understand what you're building. When you start showing them images like the ones on the right-hand side, they see the interchange, they see how it's going to look like. Finally, we mentioned earlier on how the operation and maintenance team had been involved since the very beginning through our BIM committee. Before the design is released, we always send it to the O&M team for a quick review, just to ensure that we're not creating difficulties for the future maintenance of the assets. And just to give you a quick example, this is a photo of Wraith Interchange Pump Station, which the design had to be altered in order to provide a safer and easier access for the maintenance crews in the future. And now Mark will finish with the key project outcomes.
I guess that gives me 40 seconds.
Yes.
Okay, so really quickly. The delivery of BIM in 2014 and without an EIR in place, I would say was an innovation in itself. Client involvement is key in terms of delivery of level 2 BIM. Defining the appropriate level of detail at the outset is very important. It's a very powerful process in terms of complex infrastructure, that is Wraith Junction in this instance. It streamlines the interaction between design and construction, and it multiplies the efficiency and reliability at the construction stage. It's key to successful stakeholder engagement. We've seen on large projects here, the CORB and such, that have been held up for a long period of time. And finally, it has been identified as a Pathfinder project for the definition of the Scottish BIM mandate, which is due to come into place in 2017. And finally, it is instrumental, and it has been instrumental in allowing us to become design lead on a major project that is High Speed 2 we've been working on for the last 4 months. Thank you.
Thank you.